I haven't recorded. I haven't started recording.
Oh, sorry.
I've got the excuse of being twice your age, guys. So, yeah. I'll blame it on you if I forget to record, okay? All right. So, the whole 10 series, right from 10.0.0.0 to 10.255.255.255 is the private range in Class A, right? In Class B, we have the
yes.
172.16.0.0 through 172.31.255.255 there. And in Class C, we have the
Yeah.
192.168.0.0, that complete range there as the Class C private, right? Isn't that what we did yesterday?
Yes. Yes. Yeah.
So now let's talk about something called, let's talk about an IP address. Let's say 192.168.5.10. What class and what state is one?
C class and private.
Class what?
Class C, it's a private IP.
It's a private range. Yeah.
Class C, and it is the Class C private range. Right. Now, every IP address, remember what I told you, the IP address contains the information about the full address, including like your name, your street, your state, your country. It's just like a normal, what do we call it? What address is that? Your postal address, sorry. Right? Your postal address contains all these details, right?
Yes.
Likewise, an IP address contains the full um, what is the particular machine's number, what network he belongs to you, and that typically can show you which part of the world that IP belongs to. Like for example, I'm connecting from somewhere in India, right?
Yeah.
So if I go to Google out here and show my IP address, okay, now that is showing me my IP version 6 address. See, that IP address is showing me what? That my ISP is Geo, and I am in
Yes.
Asia, I am in India. In fact, it's showing me clearly that I'm in Karnataka, I'm in Bangalore, right?
Yes.
So from
Yeah.
an IP address, if Google can tell me, or some one of these websites, what's my IP address.com, which is located God knows where, he can tell me that I'm sitting in Bangalore and that particular latitude and longitude. Don't you think that means something? That means if I'm getting this IP address in Bangalore, then the IP addressing authority knows exactly which place this IP address goes to, almost like a street address or a postal address. You understand what I'm saying? Hello, guys, are you able to hear me? Hello.
Hello.
Yes.
Yeah.
Yeah,
Very very slow.
I think we have a problem with the audio. It keeps dropping in and out.
Yes.
But anyway, as I was saying, do you see the information on the screen?
Yes.
So somewhere out on the internet, a site called "What's My IP address?" Based on the IP address that I am coming from right now, my machine is coming from now. He's got the information that I'm sitting in Bangalore. So are you understanding what I'm saying here?
Yes.
From my IP address, they were able to figure out what my location is. Right? If you
Yeah.
try the same thing, connect to the internet, you go down to your browser and you go to this site, what's my IP address.com. In fact, it will show you where you're sitting in most places. Of course, there are ways to get beyond this, but normally we wouldn't want to, right? So an IP address is able to figure out exactly on what network, what area your machine. Now, Based on this IP address, how do you think that happens? So some part of this address should mean something, right? Some part should be the machine's
Yes.
individual address, some part should be the network address. So every IP address basically has two parts, right? One is what we call the network side and the host side. Meaning, out of the 32 bits, some bits are reserved for the network identification, to which network this computer belongs to. And the balance of those would define the individual host address. You understand that?
Yes.
Okay. Now, if I only give you this information, would you be able to figure out which is network and which is host?
No.
You really wouldn't, right? I'll have to have some information along with this, which identifies, okay, which part belongs to the network, which part belongs to the host. This is where we use something called subnet mask. I'm sure you have seen what subnet masks are. If you go to your machine, you'll probably see something like 10 dot something dot something dot something, 255 dot something like that,
Yes.
right? If you go to your machine's IP address, for example, if I go to mine, I go there, I go to my network, I go to my network information. I am going to right click on my Wi-Fi, which is, I call it Dream On. You know why I named my wireless access point Dream On?
No.
No.
Because when I was doing my
That's
ethical
a
hacking
SSID name.
sorry,
Is that the SSID name?
no. When I was doing my ethical hacking training, I used to pretty much break into every wireless access points I used to see around, right? Just for the practice, okay? And it was all for good purposes. Trust me, I'm not a bad person who breaks into other things. But for the sake of knowledge, I did break into quite a few servers and networks. And then I was using my network, and my friend tried to break in, right, into mine. So that is the day I named it, oh, buddy, Dream On, trying to get into my network. And then I,
Oh.
have multiple networks, so it became Dream On 1, Dream On 2. So that's how the Dream On thing came. Anyway, if I go to my status here and go to details, right, this will give me all my information. Now see, what is my IP address here? It's showing a 192.168.43.64.
Yes.
Yeah.
All right. And what is the next bit of information here?
Subnet
That's
mask.
a separate
Subnet
box.
mask. And what is my subnet mask?
Separate
Good.
host and network.
No, it's 255.255.255.0, right?
Yeah.
Yes.
Okay, which means how many bits are on and how many bits are off in that particular subnet mask?
Uh, 24 bits are on and 8 bits are off.
Exactly.
Yeah.
So if you put these two together, what does that mean? That the first 24 bits are something and the last 8 bits are something else, right?
Yes.
Okay. Now here is where your subnet mask tells you the first 24 bits belong to the network, right? And the last 8 bits are the individual name. It's like a family name and the individual names. So
Okay.
the first 192.168.43 is a network of a bunch of machines. And 64 is my machine's individual name. So a subnet mask is basically used to identify how many bits are the name of the network, like your street address, and what is that individual, the last part. Last 8 bits can be used to define machines on that network. Then, of course, there's more information that about gateways and all we'll talk about in the routing classes. So now tell me, if I give a, let's make this 0, which means I can use anything there, and I say 255, 255. 255.0. What does this mean? It means that much belongs to the
Network.
network. I cannot change that. Like I cannot change my family's name. I can name my kid anything I want, right? But do you think I can change his family name?
No.
The
No.
family name remains the same, right?
Yes.
Yeah.
Exactly that. Now, this is the network you have been given, which means you cannot change that. Now, this part is where you can play. And here it says what? These 24 bits, the first 8 plus 8 plus 8, 24 bits are the network. You cannot play with that. But the last, how many bits do I have here? In this last
8.
octet, I have 8 bits here, which means I can use those 8 bits in either this combination or up to this combination. Everything in between I can have on my network. I can have that many machines on my network. Now, with this IP address and mask, how many machines can I have on this network? Think, guys. How many machines are possible on this network? Keeping in mind the fact that you cannot change the network.
I think 256
Anybody has got a
or
different number?
255.
256.
Yes,
Yeah.
absolutely. Because you have got these 8 bits to play with,
Yeah.
right? So I can have IP address starting from 1, 0, 1, 2, 3, 4, all the way to 255, right? Because I've been
Yes.
given this complete octet to play with. That's what the subnet mask is doing there. It's going to tell you what you can do and what you can't do. Which part of it is your network address, which part is your individual machines, how many machines you can have on the network.
Okay.
Now, when we talk about the classes, class A has got a default subnet mask of 255, 0.0.0. So when I give an IP address called 10.0.0.0, class A's default mask is 255.255, sorry, 255.0.0.0. Now, which means on a class A network, how many machines can you have? And what does this mean actually?
250.
Actually, this means what? That is the network part, right? You cannot touch that. That's a family name. You cannot mess with that.
Yeah.
Which means how many bits do you have left to play with?
2 raised to
24.
24.
Exactly. On one of these networks, the 10 network here, what it says is you have 2 raised to
24.
24
24.
machines you can have in that particular network, or roughly 16 million,
Yeah. 56.
right? A class B address has a default subnet of, for example, let's say 150.10.0.0. What would this mean? That that is something you cannot touch, right?
Change. Yes.
Change.
You have that much to play with, which means you have 2 raised to
250.
uh 2 raised to
16.
16, right? 8 here
Yes.
and 8,
Yeah.
which means you have about 65,536 individual hosts you can have on a class B network. And coming down to your class C, let's say we have the default sub. I'm not saying we can't change this. What I'm saying is this is the default, right? We know that defaults can be changed and we will. That is the default subnet mask of a class C address. Let's say 200.5.10.0. It means that part is the network, right?
Network part.
And
Yes.
this is what you have to use for your individual
8
hosts.
bits.
Which means how
Yes.
many
Yeah.
machines can you have on one of these networks?
2 to the power
256.
8.
2 raised to 8,
256. Yeah.
which means maximum of 256. Are you getting the picture here?
Yes.
You have a home
Yeah.
network, a small office network. We would typically use a class C addressing scheme. Why? Because the maximum address that a particular network can give you is 256. But if you are an enterprise company and your office has got like say 3,000 people in it, you would more likely go and use a class B network, right? Because each class B network can give you up to 65,000 hosts.
Yes.
Or if you are, I don't know who you are, if you're really big and you really have a million machines in your office, well, go ahead and use a class A, right? So typically class A's are only assigned to major ISPs. And for your information here, the last IP version for class A range was assigned in 2010. That's it. No more class A range is free to assign to anybody. So we really are running out of IP addresses,
Yes.
right? So now we come to the
Yeah.
problem here. So this is what is, and this is what we call classful IP addressing. You understand what I'm saying about classes, right? That class A can have only 16 million, not less, not more. Class B, a single class B network can have only that much. A single class C, only so much. Which is why this was called classful subnetworking. Because we define the number of machines you can have based on the class, right?
Yeah.
All right. But what is the problem here? Suppose I have, say, 10 machines to put on the internet. Let's say 3 web servers, right? 2 mail servers, and I don't know, 5 FTP servers, whatever. So I've got 10 machines to, put on the internet, which means how many public IPs would I need? 10 of them, right?
And
And
yes.
Remember that each individual machine or device on the internet needs one public IP at least, right?
Yes.
If I want to put
Yeah.
10 machines on the internet there, I need to go to my ISP and say, oh, Mr. ISP here, I need to put 10 of my systems on the internet to be publicly accessible by everybody on the internet. So I'm going to need 10 IPs, right?
Yeah.
Okay. But based on this last screen where we talk about classful subnetting, what is the smallest size of a network I can make?
based on what?
Based on this screen where we talked about the default class mass and default size of networks, what is the smallest size of a network I know how to make?
Class C.
Class C. And what is the size?
256.
Exactly.
256.
And what is the largest? 16 million.
16 million.
Right. Now,
Plus A.
what about this? How many do I need?
10.
Yeah. So this is like remember you used to go to a textile store and you used to buy material to get and you used to go and get it tailored at one time. I don't know whether you people have done that.
Yeah.
You want to make
We
a
used
couple
to.
of shirts. You used to go to the tailoring shop. They show you this big rolls of cloth, right?
Yes.
Okay, and you like something and they say, oh, okay, fine, I like this. That's how we used to do it at one time. Nowadays we don't do that, I'm sure, right? The days of tailoring are
Yeah.
gone. What if the shopkeeper told you, oh, you like this pattern, here, take the whole roll, because I don't know how to do
No.
anything smaller? What would happen then? I mean, imagine you carrying the whole roll of cloth home, right? And then
Yeah.
cutting off a piece and using it for this thing, and then what happens with the rest of the roll? You're wasting it, right?
Yes.
Similarly here, in those days, the ISP knew how to make a network of 256 at a minimum. So somebody goes and asks, hey, I need to put some servers on the web and I need some IPs. The ISP used to say, oh, go ahead and take a class C. Enjoy yourself. Have fun.
Okay.
So which means I end up using 10 of those or 15 of those,
Investing.
and then the balance of 240 is lying there. And because it has been assigned to you, it cannot be assigned to anybody. That is
Yeah.
something
Yeah.
we discussed yesterday.
Yes.
Yes.
So you see what the problem is? This is what happened in the initial days of internet. In fact, the University of Utah, they were assigned, I believe, two Class B ranges. You remember the size of a Class B network?
Yeah.
Yes.
65,536,
55.
which means those guys had about 130,000 IPs. And you know what the fun part? Over 2 decades, they only use barely like 4 to 5,000 of them.
Oh.
So imagine 125,000 IP addresses just lying there doing nothing, while literally the third world countries we were like struggling to get IP addresses.
Okay.
Of course, then they went ahead and chopped it up further, and they gave them a few thousand, and they took it the rest back and then redistributed to the needy rest of the third world countries. Of course, that happened a little later, but for a couple of decades it was lying there doing nothing. So what do we need to do? We need to become tailors, right? We need to
Yes.
be able to
Yeah.
take a subnet of IPs, and we need to be able to chop it up into little pieces, which more or less fits our network requirement or the size of our network, right? Guys, can you give me 1 second? Getting a call.
Yes. Yeah.
Okay.
Yes.
Hello.
Hello. Yeah.
Yeah, that was my kid calling up to remind me that he has got a school trip on the second, and more importantly, that I have to pay for it. I mean, I think that was the important part, right? Yeah. All right. So
Yes.
we know where we stand right here in this case, right?
Yes.
All right. So now we are going to get into the most important part, which is called subnetting. Meaning you take a network and you are able to tailor it into smaller networks based on your requirement. Done?
Yes.
So you understand why we need to do it, right?
Yes.
See,
Yes.
with private IP addresses, we don't really care, right? You can take a class A range and you can have 16 million and you can do whatever you want with it. But when you're talking about public addresses, they are at a premium, right?
Yes.
So subnetting is something that is and subnetting is something, if you're going to be in the networking industry or in the IT security industry, or in your collaboration, which is voice and video, any of those streams which are infrastructure, network infrastructure based or security based, or voice or video over networks are related. Subnetting is something that you will start doing on day one of your career, and you will keep doing it in one form or the other till the last day of your career, right? As long as
Okay.
TCP/IP is
Yes.
involved, subnetting, understanding a network, the size and the shape of it, that is something you will do every single day, right? So this is the pillar there, one of the major pillars of networking. You understand TCP/IP and the subnetting well,
Yes.
you are a little bit of the way there. Done.
Okay.
Okay, so let's take oops, I don't want a snapshot, I want a new page. So let's do this. And before starting that, you have to remember that normally by default, only machines belonging to the same subnet can talk to each other. For example, you all know what a switch is, right?
Yes.
Or a hub, some sort of a device that connects all your systems together. So you have like a few systems hanging out of this device like that. So that's your PC1, PC2, PC3, and PC4 here, right? And this guy has got an IP address of 192.168.0.5, 192.168.1.5, 192.168.0.7, and 192.168.2.7, right? All of those I've got the default class mask. I've not played with them. So basically tell me which all machines can talk to each other here.
First and third.
3 and
Yeah,
third
machine
and
one.
first.
First and third. Because one, you know this range. You know this IP address. You know this is a class C private range, right?
Yes.
All of them?
Yes.
Right. Which means what's the default class mask of class C? 255,
What? 255.
255,
5.
255.
255.0.
255.
Which means in
Yeah.
all these cases, those first three octets belong to the network, right?
Yes.
Yeah.
And as we just discussed, only devices belonging to the same subnet can talk to each other, which means this part has to match for them to talk to each other. Correct? Your answers
Yeah.
are
Yes.
exactly correct. I'm just trying to, drill down a little bit more. So these guys, neither will they talk to each other, nor will they talk to those guys, right? Only these two guys are going to talk to each other. So now keeping that in mind, let's say I have this network. Let's say the 192.0.0.0 network, right? What is the default class mask?
255.
255, 255, 255, 0.
Which means that is the
0.
network. I cannot touch that, which means I've got 8 bits to play with and I have a total of 256 possible hosts in that network, right?
IP address.
And these 256
Yeah.
guys can talk to each other, right? Without any difficulty, because they belong to the same network. As long as they are connected
Yeah.
together using some switch or a hub, they will talk to each other. They don't need anybody else in between,
Yes.
right? Now,
Yes.
Yeah.
I need to say I have three departments in my office, in my company. Let's say we have the accounts departments, and let's say we have the marketing department, and let's say us, the good guys, the IT department, right?
Mhm.
Now, in my accounts department, there are, let's say, um, 50 people. That must be one big damn company. Anyway, so there are 50 people, which means 50 PCs normally.
Yes.
And in my marketing department is, let's say, we have about 100 people. And IT, let's say, 10 people, right? Now, from what I have,
Okay.
this base network of 192.0.0 something I need to create three networks. I need to chop it up into three different networks, which more or less fits the number of PCs in these departments. Make sense? What you're trying to do here? Yeah?
Yes.
All right. So how do we go about it? How do we chop up this network, which has 256 machines, as we know, into three pieces?
We have to make like a VLAN.
VLAN is a different concept altogether. That comes in pure switching, right? Within VLANs, we give different subnets. That's a different point. VLAN is a pure switching concept where we logically cut a switch into multiple pieces. Virtually
Yeah.
cut a switch into multiple pieces. That's something we'll come to on the very first day of our switching, or rather on the very first day of CCNA. We are still pre CCNA, guys. We're still in preschool, kindergarten. Hmm? So, see, the way to think about this is how many bits do I have in this network for hosts? That's the first question you need to ask yourself.
256.
No, how many bits? We think bits now.
Oh, 8.
We have
8
8
bits.
bits. And if you have 8 bits, how many machines does that give us, or how many IPs?
256.
Exactly. What is our requirement here?
50.
160.
Right. So if I have 8 bits and it gives me 256 machines, I do not want a network of 256. I want a network of 50 machines. Which means now the question we need to ask ourselves, how many bits should I use to get a network of 50? You understand that logic?
Yes.
I have
Yeah.
8 bits, which gives me 256. I do not want 256. I need 50. So how many bits do I need? Clear on that question?
Yeah.
Yes.
Because that question is what is going to make your subnetting life much easier, right? Let's go ahead and look at set up our conversion chart here. Let's say 1, 2, 4, 8, 16, 32, 64, 128. 8 bits, right? Yes.
Yes.
Yeah.
All right. So what I have now is 8 bits. So that means 1, 2, 3, 4, 5, 6, 7, 8. Which, if I look at it, I should get
Yeah.
128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 to give you a total of 255. That's what we have right now.
Yeah.
Isn't that what we have here now?
Yes.
All right. Now the question is, for 50 PCs, how many do I need? Oh, skip the page there. Yes. So we know that 8 bits gives us a whole bunch of this thing. We do not do that. Now the question you're going to ask yourself is, to have a network of 50, how many do I need? So how many do we need? Not enough. Not enough. Guys, are you still able to hear me?
Breaking up, sir.
Yes, it did give me the message here about the audio part. Let's give it a few seconds for it to come back up. All right, are we good?
Yes.
All right. I think there is a problem with the network today. It keeps, you know, playing peekaboo with me. All right. So the question we need to know, we need a network of 50 machines, right? So the question we are going to ask ourselves is, how many bits do I need to make 50?
Yeah.
So not enough, not enough, not enough, not enough, not enough, not enough. That's too many, right? So which means we need to stop somewhere here. Correct? We need 50, right?
We can see anything, sir.
Yeah.
What do you
Alright.
see happening here?
Now
Let me see what you're seeing.
Yeah. Now we
it's
can see.
Let me see your, what do you see? Oh, are you seeing desktop or are you seeing what I'm writing?
A desktop.
Desktop.
Okay, now let me bring up my other screen. Are you getting my the writing screen?
Yes.
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 All right. So this is where we counted off, right? 1 is not enough, 2 is not enough, all the way to 32. We need 50. 64 is too many. We don't need that. So your 50 is somewhere here.
Yes.
Yeah.
So
So
how many bits
three
does it?
bits maybe.
No. How many bits here? It takes 1, 2, 3, 4, 5, 6 bits, right? It takes
Yeah.
6 bits to make a network of size 50, correct?
Yes.
Yeah.
All right. So now let's take down our 192.0.0.0. That's my original subnet, right? And if I write my mask 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Isn't that what we had? The class C mask
Yeah.
255.255.255.0.
Yes.
All right. So we have these 8 bits to play with, right? Originally, we had 8 bits, right?
Yes.
Now we decided that for our first network of size 50, we only need 6 bits. So 1, 2, 3, 4, 5, 6. That's what we need. Just like this line here.
I think we start breaking out again.
I know, I'm getting that message here. Guys, I'm going to try to reconnect, right? So I'm just going to drop out for a second and come back online. Yeah, Geo is dropping actually time now, yeah. I don't think it's a problem with the Geo. Because
Second strength.
hmm
Pulan. Huh?
it's not a problem with the Geo, it's a problem with the website. Hello? Hello?
Oh, yeah.
Yes.
Yeah, I don't think the problem
So,
is with my network here. I think the problem is with the website. The go to meeting website we had, the platform we are using,
yes.
Hmm.
because my speed is showing up at a steady 20 Mbps here, and we don't need more than 512 kbps to keep this connection going. So I think maybe the site is a little overloaded today. It happens sometimes. Nothing much we can do about that. So do you have my screen, guys? Do you have my screen?
Yes, sir.
All right. Okay. So are you with me till now?
Yeah.
Yes.
We need 6 bits to remake a size of a network of size 50. So on our subnet mask, what we're doing is we are assigning this 6 for which part? Is it the network part or the host part? On the right is always the host part, right?
First part is
And whatever we don't need, we are throwing it into the network side. From zeros, we are changing it to
1 1.
One.
yes. So now if I reconvert this back to decimal, what do I get?
254.
255,
255.
255, 255, and on this we have 1, 1, and the rest are all zeros,
Yes.
which means I need to use those two, right?
Yeah.
So what is
Yes.
128 plus 64? 164
192.
is
90.
192. So my new subnet mask here would be 192,
Okay.
which means how many bits are on the network now and how many for the host?
2 bits on the network
Uh-uh,
and 6 bits on the host.
uh-uh. 8 plus 8
Okay, okay,
plus
yeah.
8
8
plus
plus
on the
plus
2.
2.
network side, which takes us to how many now? 24 plus 2, right?
20.
24
Remaining
to
6
26.
26.
bits on the network side, and what else? 6 bits on the host side, right?
Yeah.
So which means now I can use only 6 bits for the host, not 8 bits.
Okay.
That was a big, oh my god, okay. I no longer use the paper and a pen for doing any kind of subnet calculations. You give me the size of the network, I'll give you the subnet in 3 seconds flat. Do you think I was born with a subnetting chip in my head? No.
Oh,
On the first day of subnetting, I had absolutely no clue as to what my instructor was talking about. Second day, third day, still no clue. Fourth day, oh yeah, so this is what he's talking about. Huh? Then I started working at it. Sixth day, seventh day, I really got good at it. Right? And then a few more days down the line, I completely figured it out. And then now it's been like 25 odd years now. Now I don't need paper and pen. The moment you say I want a network of this size, I'll give you the subnet mask right off my head. So what I'm trying to say here is that there's no rocket science in this. It's only practice, right?
okay.
And again, as I told you,
I'm wondering.
subnetting, we will be doing quite a bit, quite a few of these problems in class before we move on, right? So no
Yeah.
worries. Nobody's expected to understand it the very first day. You think at the end of this class you understood it, but after the class, when you try to do slow, trust me. Oh, did this go there or did this go here? And that is normal. Okay, that's
Yeah.
absolutely normal. So not to worry about that. Anyway, so this is my new subnet mask here, right?
Yeah.
Yes.
Now, what is the actual size of my network? What is my network now? Starting from where? Where does it end? Now, these three in the subnet mask, anything that is 255, we don't do. We don't care. Anything that is 0, we don't care. Anything other than that is what we call the interesting octet. So in this case, that bit there is the interesting octet, right? Because
Yes.
we know this we cannot do anything with, right? So this here is the interesting octet. That's where we are going to play. Now, how do we find the actual size of our network? You take the interesting octet. What is the maximum possible in the class C? In one octet? 256, right?
Yes.
And we subtract this 192 from that. What do we get? And always remember, networks can be made only in these boundaries. You cannot have a network of 25. You can either make a network of one or two systems, or four, or eight, or 16, or 32, or 64, or 128. You cannot go and make a network of, let's say, 25 machines. Not possible, right? Because you are using these bits here, right?
Yes.
So if you use 2 bits, that means your choice is of 194. You use 3 bits, that is like 224. You use 4 bits, 240. So when I ask this question, it should be easy for you to clear it. 192. Oh well, that means there is
64.
56. It has to be 64, right?
Oh,
Yeah.
You will come to that jump sooner or later. No worries. So this means our network has a size of 24 or 64, and this is something we call the block size. That's the size of our network. And then all you simply have to do is you take your block size and add it to your first IP. Our first IP is 0. You take the block size, add to that, plus 64. So what is 0 plus 64?
192.0.0
No,
dot
what is the question
0 to
here is,
64.
what is 0 plus 64? And I'm sure that all of you will give me the wrong answer. Now I'm challenging your simple arithmetic, school day arithmetic. What is 0 plus 64?
you mean based on IP or based on?
No, no, we are not in the outside world. We are in the IT submitting world now.
Oh, 72.
Seriously, 0 plus 64. Ah, man, that is too much.
65.
Is it?
No.
I thought for a second that you're going to nail that answer.
Six.
It's gonna be
Give me
64.
1 second. Give me 1 second. I'll tell you. Just 1 second. 256.
No. All I asked you to do was add 0 and 64. 0 plus 64.
It's 64.
65
Okay, how do you want to
Yes,
start
yes.
counting? You want to start counting 1, 2, 3, 4, or do you want to start counting 0, 1, 2, 3, 4?
in networking 0
0. So what should you
It's
get?
66.
No,
65
it's 63, guys.
Oh,
See,
come.
okay, I'm going to ask you to count from 1 to 5, but you use your finger to tick it off, right? Count to 5 in the submitting class, not outside.
4.
No, you count to 5. How many fingers do you get? I'm saying count to 5, huh? How many fingers you got?
5.
five.
No. First finger
Means
says 0, second finger says
I
1,
mean
2, 3,
it's 4.
4, 5. You actually got 6 fingers, guys. I'm asking you to count to 5, right? In the normal world, you would say 1, 2, 3, 4, 5. 5 fingers, right?
Yeah.
But in the submitting world, how do you count? 0,
1
1,
0,
0
2,
1.
3, 4, 5. 6 fingers right there, right?
Yeah.
So if you start counting from 0 and tick off 64 fingers, what do you think you'll reach? You'll reach 63.
yes
Start counting from 0 and tick off
yes
64 fingers. You will reach 63 because 0 is there, right? If I start counting
yes
from 1, it is 64. If I start counting from one step before 1, then the last number should be one step less, right?
yes
So your network is going to be from 0, that is 192.0.0.0 to 192.0.0.63, which means on your network, your IP addressing scheme will be this. This is your first network right there. We asked for a network of 50, right?
yes
And we got a network of 64,
63 I mean
64,
64
including 064.
yeah
Now comes the
Yeah.
small catch here. The first IP address of any network, I will repeat, any network is called the network ID, which means that is how we would refer to this network. And the last IP of a subnet is referred to as the broadcast IP.
Okay.
Meaning this IP is how we refer to the whole network. This last one is the broadcast IP or ID, which means any packet I send to this particular IP, that is the 192.0.0.63, every machine on that network will get a copy. If I need to send something to everybody on that network, I would send it to this IP. Which what
Okay.
that means is I cannot use these two IPs. So which means I can use from 1, 2, 3 all the way to 62.
62
So out of a network of 64, my usable IPs for machines will be 62. Remember, in any
62
network, you lose the first and last IPs. You cannot assign them to machines. Got it?
yes
Yes.
Vaguely. That's all I expect at this moment. Don't worry. All right, let's take our second network. Right? So here we had the original network of 192.168.0.0, and the first network size we required for the accounts department was that. And we said, okay, 192.168.0.0 with a mask of 255, 255, 255.192 is what we made, right?
yeah
And that in effect means 192.168.0.0 all the way to 192.168.0.63, right?
yes
Yeah.
All right. What do we have left?
100 PC for marketing.
No, 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 no. What IP is left now? Our original network was that to 255, right? 0 to 255, right? Out of which we have
Yes.
chopped off a little piece there. So what is the next? What is left now? 192, 168, 0.64, because we have used up to 63, right?
Yes.
Yeah.
64 to 255 still left with us. The roll of cloth is still there, right? We have chopped off
Yes.
one
Yeah.
piece. The balance of the roll is still there, right? And what is our next requirement? What was our next size?
100 for
Okay,
marketing.
right. Now I'm going to make that a little smaller here because you always do the largest size first. So let's make this guys 25. Let's kill off some of the marketing guys,
Okay.
right? Let's
Okay.
shoot 75 of the
Yeah.
marketing guys because those guys are terrible anyway. All right. So let's say my marketing team size is 25. I need 25 people, 25 IPs, 25 systems for the marketing team. Okay. Again, we ask the same question back. We put the original subnet mask there. That's what we have, right? Originally,
Yes.
we ask the same question again. I have 8 bits to play with. Gives me 256. I do not want 256. I want 25. How many bits do I use to get 25? Wasn't that the question?
Yes.
Yeah.
All right. Let's go up here, clean up this guy a little bit here, and ask the same question here. Not
5
enough, not
bits.
enough, not enough, not enough, not enough. Too many, right? That means
Yeah.
25
Yeah.
stands somewhere here. How many bits? 1, 2, 3, 4, 5 bits, right?
Yeah.
All right. So let's tick off 5 bits here. 2, 3, 4, 4, and 5. And what we don't need, we are going to throw it into the network side.
Network.
So now when we reconvert this 111 and all zeros, what do we get? 111 and all zeros here. That means 128
60,
plus 64 plus
128
32
plus 64 plus 32.
should give us 128 plus 64 is 192 plus 32. Here,
224.
224.
yeah, normal math here, guys. Don't do it. I've seen this happen. Once we get to that zero thingy, then you start trying to count from zero everywhere. And I even actually gone out to the street and started counting from zero. I had an argument with the shopkeeper. Right? I said, no, 0, 1, 2, 3, 4, 5. You gave me only 5. He says, no, I gave you 6. You understand where I'm going with that, right? I've actually done that. All right. So now if I reconvert this back, what do I get? 2 to 4 here.
Yeah.
My new subnet mask, right?
Yes.
Isn't that what we did here? 111, which is 224. How do we find our block size now? We take the maximum of a network and we subtract our
Fine.
interesting octet from there. What do you get?
16.
Oh, try again.
25.
No, man, you suck at math, you guys.
32.
Exactly. I told you. All I've done so far is, scared you got you scared about your math. All right.
My math
So
is always weak.
32 is your block size, right?
Yes.
Yes.
What do you do with your block size? You take your block size and add it. And now this is the fun part. Add it to the first IP. So plus 32. Okay. What is 64 plus 32?
Oh my
I
God.
love this part.
96.
Got it, guys.
95. It
Yes.
goes
Oh
up to
God.
90.
It's very simple. Do your simple math,
30.
right? Do your
Yeah.
simple math. 64 plus 32 as you would do in the outside world, right? What do you get? 96?
96
And
minus 1.
since we are not counting from 65, remember this is always inclusive. Here we started counting from 0. Here we're going to start counting from 6. So just remember, add normally, but minus 1 always in the end. That's what we did in the first one, right? 0
Yeah,
plus
we
Yes.
put the
64.
zero.
0 plus 64, in normal world we got 64, but in this world, since we are starting counting from one step before, we minus 1 there. So here again, 64 plus 32, you get 96 minus 1, which means that would be,
95.
and that is your second network. Remember, the first IP is called what?
Network IP.
The network ID or the network IP, both are correct. And the last one is your broadcast
Broadcast.
ID, which means those cannot be used. What you can use is from 65 all the way to 90,
6,
94,
94.
one before, right? That's the last IP. So out of a total of 32, you can use 30. Total was 32, right? Our block size was 32. We added 32, right?
Yes.
So our network 64 to 95 is actually 32. But since I'm losing the first IP and the last IP, my usable IPs would be 30. I can support 30 machines. Does that solve our
Yes.
purpose here?
Yes.
It does. What do we have left? We have used up to 95. So 192, 168, 0.96
Got
to 255 is
96
still
to
left.
225.
The roll of cloth is still there. What is our next
Yes.
requirement? 10. Tiny network, right? Alright, let's put our original mask back in. So we need 10 for us, the good guys, the IT guys. So original mask of 255, 255, 255, 0, which would be in 8 bits here, as always. Again, let's go and ask that question. How many bits does it take to make a network of 10 size? Not enough, not enough, not enough, not enough. Too many, right? That's what 10 is.
Yeah.
Count of
Yes.
the
4
bits.
The
bits.
4
1,
bit.
2, 3, 4. So let's take 1, 2, 3, 4. Whatever we don't need, we send it off to the other one. Right? So 4 bits on the network, 4 bits on the host here. Let's go back here. 1, 2, 3, 4. So we need to add the first 4 bits. So 128 plus 64 is 192, plus 32 is 224, plus 16 is 240.
240.
Correct?
Yeah.
That would be a 240
240.
there. So let's come down, find the block size. As always, we subtract our from the maximum. So 240, and what do we get?
16 bit.
We have 16 as the block
16 block
16.
size.
size.
That's called the block size there. So we go up there and we take that 16 as our block size and we add it to the top. So what is 96 plus 16? 96
112.
111.
111.
111.
Exactly. So that would actually give you 112, but remember the minus 1, so you got 111 there. So that would mean your 192, 168, 0.111 is your broadcast ID. That is your network ID right there. Usable IPs for machines starts from what? 97 through,
110.
which gives you a total of 16, but only 14 are usable, right?
Yes.
Yes.
And that means you have your subnet size of 10 for the IT guys. Done?
Yes.
Yes.
We are at 7:47. We've got time to do one more class C problem, right?
Yes.
Now, tomorrow we will do one more class C problem at the beginning of the class, and then we will continue on to do class B problems.
Okay.
You think class C is difficult?
Same timing?
Yeah. Why?
Because you told us that one class will be in the morning.
No, correct. After our TCP/IP, because once we complete our subnetting and then we talk about the layer 2 a little bit, then that is it. We are done with your pre CCNA, right?
Okay.
That is when I have to bring in a device and show you how to connect to it. So only on one day I'll show you how to connect to the device. After that, you and me, all of us will be using our GNS3 labs to do that. Because
Okay.
there are certain cases where I've seen people learn completely on the lab simulations. When they actually got a device in hand, they call up and ask, "Sir, I've got this switch in my hand. What do I do with it?" You know, there's a disconnect between the real world and the lab world. So I need to show you how to start. When you take a device out of the box, right? You're working for
Yes.
some company, they bought a new router or a switch, and they said, "Oh, go ahead and configure this." You should know what to do with it when you take it out of the
Yeah.
box for the first time, right?
Yes.
And that is the reason
Yes.
I actually do it with the physical devices for one day, just so that you know how to start off. After that, everything, the simulation is 99% similar to what happens in the real world. Why do you keep doing that, Swati?
What?
As if like,
I'm tired. I'm wondering, it's not kindergarten at all.
sorry?
I don't think it's kindergarten.
See, as I told you, this is a new topic, right?
Yeah.
So, yeah, there's always that learning curve. The first few days of theory, see, the first few days are boring, right? Because it's pure theory.
Yes.
But this is like medicine, guys. You don't have a choice. Might be bitter, but you have to take it,
Yeah.
especially the subnetting part. In fact, it is all about the subnetting part. OSI layer
Yes.
differences, you could have read it anywhere and learned it, right? Wouldn't make a bit of a difference. Tomorrow I'll give you a website where you can continue these practices. Okay, so let's quickly do one more problem, just so that we have a slightly clearer picture of this.
Okay.
Okay.
All right, let's say I have the 200.10.5.0 network, right? With a default class mask of 255,
Two five five. Two
255,
five seven.
255.0.
255.0.
Now, how many bits am I using for the network here?
24.
Now, so if I go ahead and write 200.10.5.0/24, does that make any sense to you?
Yes. It's you using 24 bits on that particular subnet.
Yes. This does make sense to the lazy people among us. Primarily me. You know why? Because I don't have to write 255.255.255.0. All I have to do is write /624. Now, this is the decimal subnet mask, right? This is another way of writing it,
Yes.
and this is called the CIDR notation. And that stands for the classless
Okay.
interdomain routing. Remember the classless part? We talked about the classful networking, subnetting, right? We are doing the classless. We don't care about the class here, right?
Yes.
We are
Yeah.
chopping it up into smaller pieces. So we've given up the classful part of it. So this is either called a slash notation or it's called the CIDR. This method of, and they are exactly the same, right?
Yes.
Just two ways of putting it there. Here we know we are using the first 24 bits to um, as the network part, and here that's exactly what we are writing. So if I write 16 here, what would that mean?
On that subnet mask,
255
it's
again.
using 16 bits only.
Yeah, then that
So
would
it's
change
255,
to
255
something like
0.0.
that. That the connection is clear, right?
Yes. Yes.
Because in the half time your exam problems would come this way. They would give you the question as a slash notation, so don't get confused there. All right, so quick problem here, and that's a slash 24, right? Which means how many possible hosts there?
2 raised to 8.
2 raised to 8,
250,
and that is
which is
256, right? Because we're
256.
talking about a class C here. 255, 8 bits, 16 bits, 24 bits, and the rest for the network. That's exactly what it means there. All right. Let's say again, department one. I don't want to spend time thinking of the names for the department. Department one needs 110 machines. Department two needs like 55, and department three needs like 20. Or let's make this 20. 20 is good, right? And always remember, guys, when you do submitting, do it in the descending order. Always take the largest requirement first. Correct?
Yes.
Right. So, can we do this?
Yes.
All right. Let's get our the conversion chart in place. 1, 2, 4, 8, 16, 32, 64, 128, right? So our mask,
7
our IP is 200.10.5.0. That correct?
Yes.
All right. How many do we need? 110, right?
Yes.
So not enough, not enough, not enough, not enough, not enough, not enough. 110 should be somewhere here.
Yeah,
Count of the bits.
7 minutes.
7 bits.
Yes.
So 1, 2, 3, 4, 5, 6, 7. Draw the line there. Whatever we don't need, we are throwing it to the network side. Right?
Yes.
Okay. Let's convert this back to decimal. So that is 255. We know that. Right?
Yes.
That's 255. We know that. That's 255. We know that. What is this? 100.
128.
120.
That's a simple 128. We know that. Yeah, good. So that would mean our new mask is 255.255.255 dot 128.
128.
128.
What do we do next? We try to find the block size, right?
Yes.
To find the block size, we take the interesting octet and subtract from the maximum possible. What do we get?
Yes.
127.
So, I don't do that with every math problem.
Okay, okay. Yeah, yeah.
128 is exactly half of 256, right?
Yeah,
So
128.
subtract that, you get 128, and that's our block size, right?
Yeah.
We take that block size and we add it to the top. So plus 128. What do we get? What is 0 plus 128?
127.
Exactly. 0 plus 128 in the normal world minus 1. So that would be 200.10.5.127.
Okay.
The first IP is what?
Network IP.
Network ID or IP. You cannot use it for a normal machine. The last one is the broadcast ID. That cannot be used either. Which means, what is the usable range?
1 to 124.
Huh? That's
Oh, sorry.
127.
1 to 126.
Okay, so we know you have a total of 128 IPs out of which you lost 2. So usable is,
126.
does that support our requirement of 110
Yes.
Yes.
without wasting too many?
Yeah.
Hey, it's better than wasting 256, guys. We only wasted what? 16 IPs?
Yeah.
Yes.
Because we are bound by these boundaries. We cannot make a network of anything other than these. Okay, anyway, so what do we have left now?
From 128 to 255.
We have 10.5.128 all the way to 255 is left. Let's get the mask back in place. 255, 255, 255 dot 1, 2, 3, 4, 5, 6, 7, 8. What is the next requirement? What is our
55.
55.
oh yeah, right there. Okay, 55. Let's go find out how many bits it takes to make a network of 55. Somewhere here, I believe.
Yes.
How many
Yeah.
bits?
1, 2, 3, 4, 5, 6.
6.
6 bits. 1, 2, 3, 4, 5, 6. Whatever we don't need, we throw it out there. Convert that. What do we get?
192 and
We get 128 plus 64, that is 192. And
192.
as we always do, we try to find the block size by subtracting that right there. What do we get?
64.
We get 64 as our block size, and we always take the block size and add it to the top. What do we get?
65. So 191.
191. Do the normal math and remember to subtract 1 at the end, that's all. So 200.10.5.191. And that's my network ID. That is my broadcast ID right there. And everything from 129 to 190 is usable, right? Correct? So we
Yes.
have a total of what? 64, out of which how many we can use? 62, because we lost
62.
2 IPs. Done?
Yes.
What is left?
From 192 to 225.
What is our requirement here?
20.
How many bits does it make to make a size 20? Somewhere here?
Yes.
How many bits?
4.
5. 5.
5.
Oh, so, yeah.
Something like that? 5 bits for the host. Whatever we don't need, we're sending it to the network side, right?
Yes.
Yes.
Right. So that's 111. Let's convert it back to
224.
decimal. Perfect. What do we do with the 254, 224? We try to find the block size. 224. What do we get?
32.
Which is our block size. As usual, we take the block size and add it to the top. 192 plus 32?
223.
224. So it's 223. Goes up to 223.
Exactly. So 200.10.5.223. Network ID, broadcast ID, everything from 193 to 222 is the usable. So a total of 32, out of which 30 is usable. Does that solve our problem?
Yes.
And we still have 224 to 256.
256.
So that's about 32
255.
IPs still remaining in the original row.
Yes.
In the old world, when we were doing classful subnetting, I would have had to give 3 full class C subnets to this, right? If I didn't know how to chop it up. You understand why we went into the classless subnetting now? Or why we had to chop it up into little pieces?
Yes. Yes.
Now, don't worry about it too much today, right? Take a problem and try to solve it. If you get stuck on the way, go back to the video, check it. because tomorrow morning we're going to start with one more class C to, because I've always found it better. You try something, you get a big a part of it, and then you give it 24 hours and you try again, you get it much clearer, right? So try to do a
Yeah.
couple of problems. If you get stuck, go through the videos, try again. If it does not happen, which is fine. If it happens, great. We're going to do it again tomorrow. Don't worry, right? So it does
Okay.
take 2 days, guys, to get through this thing, right?
Yes.
And tomorrow I will be giving you a book, that one right there, right? That's a workbook. You can actually print it and work your problems on this if you want. Everything we did, different methods of finding. See, what we did to subnet is a shortcut method. All right. The method I'm using
Okay.
is a shortcut method. There are multiple shortcuts out there. So I'll give this book to you at the end of tomorrow's session because I want you to have at least one method clear in your mind, right? Then you take time
Okay.
over the weekend and go through this. They will give you different methods, more detailed explanation of all the conversions, and all the information we spoke about is right here, right?
Mm.
So I'll upload this book tomorrow.
Okay.
All right.
Yeah.
All right. Any questions?
Nope.
No, sir.
That is good. That is good. But again, as I keep telling you guys, learning subnetting is a 3-day thing, right?
Yeah.
And
Yes.
being able to subnet in your head probably takes 10-15 days. So don't worry about it. That's not how it normally happens. And tomorrow we will try to, list out all the steps in doing this, right? It's a 5-step process. I give you a class A problem, a class B problem, a class C problem. These 5 steps will give you the answer, trust me, right?
Okay. Okay. Yes.
So you guys, I know you're tired, you're mentally tired. God, what have I gotten myself into is the question some of you are asking now. Right? Okay. Fine. You guys have a good evening or a good night or depending on what time you guys turn up. So I'll see you tomorrow,
Thank you, sir.
same
Have a
time.
good day.
Sorry?
Yes.
Okay,
Thank you,
sir. Have
sir.
a good day.
Okay, fine.
Thank you.
See you guys.
Have a good
Bye-bye.
one. See you. Goodbye.
Okay, bye-bye.